All right, sir, whenever you're ready.
Great. Thank you. Uh, can you see my screen?
Yes.
Yes, yes.
Great. Good morning, everybody. And thank you, Josh, for having me here. My name is Nimit, one of the co-founders at Voatz. Voatz, as some of you might know, is a very new elections company. We've been around for a little over 5 years, which is a very short duration in the election space. But we've learned a lot in terms of being very fortunate to be able to pioneer mobile blockchain voting in the US and in a few other countries. And so I'll share a little bit about our perspective and experience so far, and what we've seen and how we kind of are looking at the future as it evolves. So I'll go through a few slides, and then thoughts for an overview. I also have a couple of small videos if there's interest to see a more detailed tech deep dive. I can do that as well. So my background is primarily in mobile and cybersecurity. Been working in the space, trying to break things and build them together for the better part of 20 years now. And the way Voatz got started was somewhat of an accident. A few years ago, my brother and I were at a hackathon competition at South by Southwest in Austin, Texas, and we just fell upon this idea, did a prototype, and ended up winning the first prize. So that led to the eventual creation of Voatz. So I'll talk a little bit more about that later, but let's kind of start with the present. As we are all aware, um, the world has changed significantly in the last couple of years, and the need for accessible methods of voting globally is, is more acute than ever before. A lot of people aren't able to use traditional methods of voting, which is in person, using paper, or even postal ballots. And so there is a dire need to help these citizens. There's not traditionally been an accessible form of voting for them, and so that's kind of our motivation to keep working in this space. There's also been a huge proliferation of smartphone penetration, as most of you are probably aware, and the world has become mobile first, and our elections aren't mobile first yet. It's one of the few use cases which is still done in a very traditional way, and that has huge impacts as our society evolves, as more and more young people who've never actually bought a stamp to send out a piece of mail or have never written a check. And so you can imagine the impact that could have on the traditional methods of voting. So given that background, we came at it from sort of what are the pillars we need for a system like this to be safe, accessible, and also transparent and auditable. And we, sort of boiled it down to these four areas. You need to have hardware-based security, which is now available in most modern smartphones. It isn't easily available on your traditional desktop or laptop computer. So definitely smartphones have an edge there. Biometrics, which has also evolved, both what we call as traditional biometrics as well as pseudo biometrics, your Face ID, Touch ID, fingerprint scanning, other forms of sensors on your smart devices, and then remote identity proofing, being able to sit in any part of the world and still prove your identity without having to physically present an ID card. So that's really key. And then lastly, um, the distributed ledger technology, which has in many ways made a lot of the traditional processes more efficient, more transparent, more auditable. So our premise is voting using your smartphone backed by a distributed ledger infrastructure is the future. It's already happening. Uh, as of last month, we've completed 94 successful elections. More than 2 million voters have been served, um, most of them in North and South America, and now we're expanding in other parts of the world as well. We did our first governmental election in 2018, but you, I don't know if many of you are aware that smartphone voting backed by the blockchain was actually successfully piloted in the 2020 elections in a couple of states. Um, Overall, 5 states, 32 counties have successfully used the system, and it's initially in the US focused on a very specific demographic, the ones who can easily vote the traditional way, so military voters, citizens who are living overseas, and voters with disabilities. And in other parts of the world, it's available to a wider population already. In addition, we've also been fortunate to have bipartisan support. So both major parties are using the system in several states for their internal elections, their caucus voting. And the reason that's important is because it's really important for a diverse group of people to use the system to start building trust. Because as we build up into more complex elections with hundreds of millions of voters potentially voting, having that baseline level of trust from all sides of the political spectrum is really, really important in our humble opinion. Also, I'd like to highlight a couple of international projects before we jump in 2020, we were fortunate to do a national referendum in South America, which has by far been our biggest ever election, and to our knowledge, the biggest ever mobile online blockchain election anywhere in the world, where almost 1.7 million people voted. It was a fascinating project. It was actually mercilessly attacked by the incumbent government. As you might know, um, there are two governments, or used to be two competing governments in Venezuela, and the system survived, did really well, and it was a really good showcase to show that the technology has matured way beyond what a lot of critics might think it to be. Also, we did a pilot test in the Philippines, which was very successful for their citizens living abroad. So just to give you a sense of what things are happening around the world, and just in a couple of months, we're going to be launching the same project with 15 cities in Canada and Ontario for the upcoming municipal elections. So things are moving, I would say, a little bit faster internationally, but still moving in the US, slow and steady. Next, I'd like to quickly talk about sort of how the system works. So as I say, it's a mobile-first system. If you don't have a smartphone or a tablet that's compatible, there is a way to get access to a web browser-based system, but that's not the first preference for security reasons. So process is really simple. You download the app from the app stores. You get verified. You can use most forms of government photo IDs, selfies, to do the liveness detection to make sure you're authorized individual. Wherever scanning of IDs and taking of selfies is politically or regulatory reasons, it's challenging. There are alternative approaches available. The election jurisdiction can issue secure QR codes to every user that is tied to their encrypted voter information, and you can just scan that for verification. So there is an alternative. Our preferred approach is to have everybody scan an ID, take a selfie. Um, Again, you need to do that when you get on the plane, and so it's not meant as a form of discrimination. It's more meant as a way of security and making sure you are who you say you are. And you only have to do it once um, per cycle, unless you change your phone or your ID is expired or if some other security event happens. So once you're verified, you get access to the ballot depending on your voting precinct. You can mark your selections. You can optionally get a receipt to audit your ballot. You can sign on the screen if you need to sign an affidavit. So it's very accessible. One of the things we focused on is we wanted from the very beginning for a system to be tied into the legacy system. And the reason that's important is because change in the election space, big change, doesn't happen overnight. Change is very slow, incremental, which is frustrating, but unfortunately that's how the system works currently for various reasons we all know of. And so instead of just sitting back and hoping a miracle will happen one day, you have to start small and slow. So that's been our approach. So the system's tied into the traditional process. And the really neat thing about it is, even though you're voting on the phone, your ballots are recorded on the blockchain. You're able to audit your ballot on the blockchain. It still produces a paper ballot because that's the only form of tabulation that's permissible in the US at the moment. So there's a little bit of reverse engineering that happens there, but it ties nicely into the election system. All major paper ballot vendors, we support their interface. So it'll magically produce a paper ballot just as if you would hand mark that paper ballot, and it's tabulated like your mail or in-person ballot. So that links on both ends it to the legacy infrastructure, but at the same time lets you use as a voter a more modern and, in our assessment, a more secure and auditable technology. Another really interesting feature is there's an optional feature to get a receipt. So I know the concept of a ballot receipt is somewhat controversial. In our humble opinion, it's actually a really good tool to rebuild trust in our electoral infrastructure. And I'm sure you all would agree there's a lot of trust that's been eroded in the last few election cycles. And giving a random selection of voters the ability to get a receipt to audit their ballot. In our case, you take your digital receipt, you are able to anonymously audit it against the paper ballot that was generated and tabulated for you. In addition, you can check everything on the blockchain ledger, every oval you mark basically, to get additional assurance, both visual as well as mathematical. And so from a trust building perspective, we feel like this is a relatively easy and very kind of novel approach. And so far in our elections, as of the last election, more than 47% of voters are checking their receipts, which, if you look at it from a mathematical and statistical perspective, is way higher than the number of paper ballots that are audited in post-election audits, which is less than 1%. So it's a little sort of nuance to that approach that we feel is important, and we hope more people utilize this feature. It is an optional feature, so a jurisdiction can choose to turn it off. We highly recommend they use it. On cost side, so a lot of times those of us in the technology space, when we go talk to stakeholders, buyers, election officials, we have a tendency to start from the technology side of it. Oh, smartphones are great, blockchain is novel, has a lot of benefits. But what we've learned is, I think the conversation, if you flip the conversation and look at it, what's in it for the prospective user, what's in it for the prospective buyer, we've seen that for a voter, it's more accessible, especially if you can't use a traditional method. It's arguably safer as well in some cases. But what's in it for the government, what for the election management bodies, and there's a huge cost saving. There's a huge um, time saving in terms of productivity lost because a lot of time people spend hours standing in lines or traveling to these places. So as a society we can gain benefits, and governments can save a lot of that money which they can deploy in other places, beefing up cybersecurity, doing more training for staff and things like that. We talked about benefits, although the data is still early. We've only done 94 elections so far, 2 million voters, but the trend is that it leads to a 3 to 5% increase in voter participation using a system like this. And there's no partisan split, it's fairly even based on the data we have so far. And then lastly, also like to plug in a little bit about, the eco-friendly side of it. We are saving paper, even though we are in the US printing paper ballots. It's still 50% saving compared to, you save on the envelope, you save on, reprinting and a bunch of other things. And this is even after taking into account our carbon footprint, because we are currently running a 64 node network. So obviously we have a footprint. And so even when you subtract our footprint, it's fairly climate friendly compared to the current process. So that's kind of a little bit about us. And I have a little more about security, but I think I'll pause on that and just end with. So as I said, we've been very fortunate to have pioneered the space and are continuing to make improvements, and have won a few awards recently as well. So I'll just pause over there and open it up to questions. And if you'd like to see a video of the demos, I'm happy to pull those up as well.
Hey, Nimit, this is Josh Hakakian, Department of Veterans Affairs. If you could show us a video demo, I think that would really benefit the group. Um, is that one of the options that you had mentioned?
Absolutely. I'll pull it up right away. Are you able to see my screen?
Yes.
Yes.
Okay. So this is a landing page from a recent primary election in Utah, one of the counties. So typically, if you were a voter in a certain county and the county is using our system, you get access to a landing page like this, and then it has these very short videos. So I'll play the first video, which shows you how to sign up. It's a couple of minutes, and a similar one which shows you how to vote, and then I'll pull up the blockchain side of it as well. So let me play this. So this is the first part of the process where you just downloaded the app, you've just started the identity verification process. For most users, it's um, everything matches. It just takes, it's pretty quick. Um, Sometimes it may take up to a day if there's additional verifications needed. So once you're verified, you get a notification, a push, a text, or an email. And if your um, absentee voting window is open, then you can start voting right away. So this second piece demonstrates the voting flow. And as you can see here, this ballot has an affidavit, so you can sign on the screen, much like you would sign the outside of your postal ballot, and it's verified um, with your signature on record. And here you get a receipt as well, um, and then you can um, decrypt your receipt and then look at the data on the blockchain to verify as well as look at the paper ballot that was generated for you.
So this is Josh Hakakian, Department of Veterans Affairs. So Nimit, I wanted to ask you, I have 5 or 6 questions that I've taken notes on already, but I wanted to ask you if now's a good time to open this up to the group for questions. And then I'll come in at the end with some of mine. Is now a good time for questions?
Yeah, absolutely. Yeah.
Okay, I see we have one question from the chat, and then I'd like Marquis to come off mute. And the question from the chat is from Tina Spielman. She asks, what programming languages were used, and can we see some of the code?
The mobile apps.
Oh, we're having some difficulty hearing you.
Are you able to hear me now?
A little bit better, yes. Nimit, can you hear us?
Yeah, I can hear you. Can you hear me okay as well?
Yeah. It's a bit faint, but I'll go ahead and reiterate the question.
Sure.
So what programming languages were used, and can we see some of the code?
So the iOS application is written in Swift. The Android application is written in Kotlin, and the backend infrastructure is implemented in Scala and Akka. And the blockchain piece is in Go. So right now our system isn't open source. Um, it will be at some point in the future, but right now it isn't. So we don't have a source code publicly available. The blockchain piece is open source. We use Hyperledger Fabric, so you can go to hyperledger.org and look at the Fabric implementation. We use so we've written a little bit of our own chain code, but it's fairly straightforward. So that piece you can review as well. But the rest of the pieces aren't open source as yet.
Great, thank you. And Eric Fears, just real quick, Marquis. Eric Fears, he mentioned something. This is something that I had kind of mentioned to you previously, and it's one of my questions as well. He mentions that identity is tied to your app and you use the app for voting. This appears to eliminate secret balloting since identity is tied in with validation to vote. Um, so is there a form of anonymity that is added, or is there a form of de-identification? How is that aspect handled?
Yes, absolutely. So the identity verification process is basically used to make sure you are who you say you are and that you are a valid voter on the state voter roll. Once that piece is done, and then you get access to your ballot, and you sign and submit, that uses a double envelope. So it's encrypted and fully anonymized. The outer envelope has your signature, just like the outer envelope of your postal ballot has your signature. So the election officials can verify it with the state voter registration system. But your actual ballot is fully anonymized. No one can see how you voted. Each oval or square on the ballot that you mark is recorded as a unique anonymous transaction on the blockchain network. And then that is used to reverse engineer and create your paper ballot, which is printed and tabulated on election day. So there is no tie-in between you and the identity um, verification process that we've used.
Thank you. And Marquis, please go ahead.
Yeah, man. Hey, Nimit, first off, thanks for this presentation. I've been following Voatz and your progression for the past several years, and I'm pleased that you're continuing to have successes and you're growing the features and functionality, because I think it's important for the technology to prove that this is useful and executable in voting. It seems like there are two crucial pieces to making votes work, in my estimation. There's the user onboarding piece, which looks really simple from the video that you showed. But then there's the site implementation, where I think in one of the slides you detailed that each jurisdiction has to upload election definition files and things of that nature. Can you speak a little bit about the lift in getting the rules of that particular jurisdiction and how they vote, and getting that information into your smart contract architecture? This is the slide that I remembered. Can you speak a little bit about, I guess, how heavy the lift is in configuring the functionality on the jurisdiction side?
Hi, Marky. Yeah, absolutely. Happy to talk about that. So our focus has been to make this process as easy and seamless for the election officials because, as you know, cost is a big factor for them. And then how much extra work they will have to do to implement something new is always a bottleneck. So we've actually reduced their work, if you can believe that. So there's very little to no extra work they have to do, and in fact, it saves them time from what they used to do. So looking at the first part, you said election definition. So they don't have to change anything in terms of how they're designing the paper ballots, right? Because that's how they do for the in-person and the postal voting. Once they've designed the paper ballots, they basically send us the PDFs and the ballot definition files from whichever system they're using, whether it's ESNS or Dominion or Clear Ballot or other systems as well. We have then implemented a process which programmatically pulls that information, creates the digital ballots, and then provides them using an admin interface to the election officials for doing random proofing, just to make sure there's no spelling mistake, every contest got imported correctly. And so they can quickly do that, and then the system's ready to go. So it's a very light lift. Um, they actually save time in terms of onboarding voters. They no longer have to send PDFs and emails to absentee voters. The notification um, becomes automatic on the phones. If people have enabled push, otherwise they get a text and email. And then from the tabulation side, they no longer have to worry about whether the postal ballot or the one which is being submitted by military voters over email or fax, will it actually tabulate or not. Here, exact fully machine tabulatable paper ballot is generated, which they can just put in the tabulator and seamlessly tabulate. So it's a really important point you brought up. But our focus has been what are the places in the existing infrastructure, existing process we can come in, integrate seamlessly, try and avoid any extra work for the election officials, and wherever feasible, reduce the work. So that's why we kind of use this 10-step flow, so you can understand the key phases and so how the system's potentially helping save time and effort. So hopefully that gives you a picture of how that's working. It's a fairly light lift. They just have to give us the files. Everything happens automatically. So the two pieces of data we need are the ballot definition files, which they get from their paper ballot design anyway, and the list of eligible voters, which is an easy export from the state voter registration system, and that's it.
Hey, Marquis, you're on mute.
Sorry. It sounds like your automation internally kind of takes all that information and puts it where it needs to be. I had a follow-up question. I know my friend Tina has a question in the chat, but on top of that, and then even going back to your slide, I think another crucial necessity in demonstrating that Voatz works and that it's safe is the auditing process. Can you talk a little bit about some of the audits that you've been required to produce, especially around the security, well, I think you kind of talked a little bit about anonymity and pseudonymity and so forth, but in the last election cycle, and even now, it's almost embarrassing. There's this big hoopla that some of the voting mechanisms, the voting tools that we've used are malfunctioning, or they were skewed improperly. How do you combat that with your auditing approach? And that's my last question.
Sure. So I can pull up. Let me pull up a screen grab of our audit system. A moment.
And also, Nimit, I'll reach out to you on LinkedIn and send you a connection invite so that we can talk more about this offline.
Absolutely, that'd be amazing. Pull up the audit system. Are you able to see my screen?
Yes.
Great. So how the post-election audit process works is, as I mentioned earlier, a random number of voters are selected for to receive a receipt. So it kind of ties into one of the questions on the chat as well, about receipt. So you have the option of, not using the receipts, um, which is basically means not sending them to the voters. But the reason, as I mentioned, given the landscape and the erosion of trust, we feel like randomization of that receipt process is a really good way, is a low risk way of, proving the integrity of the system, and at the same time not compromising on the anonymity of the wider election. So whether you send the receipts to the voters or not, um, anonymized screen receipts as well as the paper ballots are generated by the system for auditors and election officials. And so those go into an audit system. It's basically a web app audit portal where you have three screens. You have the anonymized voter receipt. You have the printed paper ballot that was scanned on a tabulator, and then you have the data on the blockchain. And during the audit process, what happens is, so anyone can audit, anyone can sign up to be an auditor. You can be a voter, you can be a citizen, you can be a political person, anybody. So it's open. You just apply to be an auditor. You'll get credentials to the audit system. And then what you do as an auditor is you look at a random selection of receipts. You can pick any random receipt. You can pick any oval. You can then, using the anonymous ID, look at the matching paper ballot that will show up on the middle of the screen, and you can find that contest. You can compare the oval. So that will tell you if voter intent from the receipt actually matched what was printed on paper and what was tabulated. And then you can go one step extra beyond it, and also look at the math on the blockchain. I'll show you a screen grab for that too. Are you able to see the screen?
Yeah.
So this is the viewer. So as voters are participating, you'll see this move. This is publicly viewable. Every oval gets recorded as a unique transaction, and then during the audit process, you can look up every oval, look up the identifier, and then look at the actual data. We provide a mapping table, which allows you to take the base 64, find out the actual mathematical representation of every oval, and then you can actually match every oval on every ballot, and you don't have to check thousands of ovals. You can do a mathematical random selection, and that gives you statistical confidence. Because it's random, the system cannot predict which voter will get the receipt, so the system can't cheat ahead of time. So you're actually, making it, more transparent, more auditable, more safe. Now, because this is happening remotely, there is a risk that a particular voter who voted now signs up to be an auditor, does his own audit, and then he or she can take that and post it on Twitter or Facebook, right? That's something which technology can't avoid. That's akin to you taking a picture of your paper ballot at the voting jurisdiction or your postal ballot and saying, this is how I voted. And so that's that's user behavior. That's not a reason to not use a technology. So that's kind of our perspective on it. So that's a little bit about the audit. We do have a detailed audit manual. Somebody wants to look at that, I'm happy to send that as well.
Thanks, Nimit.
Sure.
Hey, Nimit, this is Josh again. I have a question. So I have to go in about 8 minutes or so. But we can continue on if there's some more Q&A. But I wanted to make sure I have a moment to get this question in. How did your organization manage to gain access to using your platform in nations where voting was typically skewed? What was that approval process like for Venezuela and the Philippines, nations where we mostly consider them to sort of have back-end pathways to their election process? How were you able to gain approval to use a platform that is demonstrably democratized?
So in both of those cases, there was a competitive RFP bidding process. And so we bid like other vendors, and we were selected in case of Venezuela by the Guaido government, and we ran the whole process with the help from local volunteers as well over there in country. So there was no, at least from what we saw, there was no possibility of any kind of sort of malpractice in the procurement process there. Philippines as well. It was a very open process for the pilot. I believe 4 companies were selected from around the world. 1 backed out eventually. 3 participated in the pilot, and it was an open process. So all the bids we won, we just won 15 elections I mentioned in Canada. They've all gone through a public procurement process, and from our perspective, that's we follow all the official procedures, and we are not privy to what might be happening, what has happened in the past. What we can assure is there is no way for anyone to manipulate the data. That includes us, any election official, any third party, any adversary. So that's the assurance we aim to provide. Anything beyond that is sort of outside our control. We can't control the media and those kinds of things. But from what we see, the process has been pretty clean and above board so far.
Thank you. I have one more question before I want to pass it back to the group. So on your application, on your mobile app, when people register and they scan their government ID, it appears that they're going to be enrolled into different voting opportunities that sort of pertain to their locality. That's what it looks like. I'm not certain. So let's say, for example, I scan an ID. My city is Pittsburgh, Pennsylvania. Mm-hmm. So my current impression is that if anyone in the surrounding area who's where I would normally be able to vote is using your platform, then it's going to automatically populate. Will I, at that point, also get push notifications saying, hey, don't forget to vote for this, is happening on this day? Would you speak a little bit to that?
Yes, absolutely. So as long as your address has not changed, so let's say, let's look at a year where there's more than one election, right? So this year there's a primary, and then there's going to be a general. So you scanned your ID in the primary, you are registered to a certain county, a certain precinct, and you voted your ballot. Now come general election, if your address has not changed, no redistricting kind of issue in your jurisdiction, then you don't have to scan your ID again. Um, it already knows your precinct, your ballot style. So as soon as the paper ballot information is loaded in, it'll create your digital version, and you'll get on as soon as the voting window opens, you get a push notification if you've got those enabled. You can get a text message. You can also get an email. So you seamlessly get reminded, and it'll keep reminding you till you submit your ballot. As far as data retention is concerned, your photo ID picture and selfie are deleted within 24 hours of verification. Those are not stored, they are not shared with anybody. The reason we delete them is we don't want to increase our risk surface. We don't want to be holding millions of photo IDs and pictures in our system. And we already have a big enough target on our back. Why increase the risk surface when you don't need it? Because all that information is available as a digital credential, which is stored securely on your phone hardware. So as long as you don't change your phone, your license doesn't get expired, your passport doesn't get expired, or there's no redistrict issue, your precinct hasn't changed, it's seamless. If any of those exceptions happen, then it'll prompt you to rescan a new form of ID, so it can make sure you get the appropriate ballot for the next election, and you don't get the wrong ballot. Does that answer your question?
Yes, that's perfect. I have one more that I want to make sure that we get on the recording, which is what barriers to widespread United States of America implementation do you currently foresee? And to that end, what sort of changes would you like to see in legislation or policy to allow an organization, either your organization or an organization doing digital voting, to continue to prosper and expand in these United States?
Yeah, I think the first hurdle is regulatory. As far as I remember, only 31 of the 50 states allow some form of technology to be used for those small subset of voters, the military voters, citizens overseas, and voters with disabilities. So I think an easy first step would be to ensure every state, each of the 50 states, at least makes minor changes to their laws, so in the election code, so at least we are serving the demographic which is most in need of this technology right now. That would be our first step. Second step, and there's been a fair amount of progress in the last year or so, particularly led by the Government Blockchain Association, is a need for standards. So we have standards called VVSG for in-person paper voting. We really need a baseline standard for digital voting. There has been an active attempt over the past decade to make sure standards are not created. Because once a standard is created, somebody's going to get certified, and then you've now you kind of expanded the footprint, and so it's unfortunate, but I think that's changing. So I think a push to get a standard in place as a VVSD supplement would be great, because then certification can happen, and then platforms such as ours and other platforms can actually get certified, which helps build in the wider trust building process as well. So that would be two. And number three is we realize we live in an unsafe world. There's a lot of rhetoric from various parts of the government demonizing anything connected to the internet. I think that needs to, our humble plea would be that needs to be, treated with a little bit of um, more of an objective lens. You know, just like people are able to vote from home using a postal ballot, postal voting has its own set of risks. Right? It's not the same as going to vote in person on a polling station. It's a form of remote voting. Similarly, this is another form of remote voting. Every method has its risks and things which are good and things which are risky, and we find ways to mitigate those risks and make things safe enough. No method of voting is 100% safe, right? We recognize that. And so to blanketly say anything connected to the internet suddenly becomes safe and should not be used, should not even be experimented with, I think that's a very, very, unfortunate um, way of portraying things. Every day we are doing billions of transactions safely on the internet. We can make voting safe on the internet. It is, it's already happening. It needs to be scaled up. And so providing support for experimentation, funding, a facilitative environment where jurisdictions can test the technology, voters can test the technology, all sides of the political spectrum can continue to test and experiment with the technology without demonizing people who are trying to make this change. I think that's really, really important. And a government, federal government as well as state governments can play a very constructive role over there by providing funding, by providing safe environments for this experimentation to happen. Because otherwise, nothing's ever going to change, and we'll be stuck in the dark ages forever. So that's, I would sort of categorize it in those three buckets. Let's start changing rules in the remaining states, so at least the bare minimum number of people who really need this can use a technology like this. Then let's start getting standards in place. And then lastly, let's talk about expansion and scaling in a very sort of methodical way. So, we create safe environments and, constructive process instead of, not allowing any innovation to happen.
Hey, thanks, Nimit. I'm going to go ahead and stop the recording here.